Hi guys, good morning and welcome to your next online math lesson. Today we are going to be talking about line plots. So let's get going. So please go ahead and start by turning to page 282 in your instruction books. The problem on page 292 says that Emma's class has a jar of earthworms in their classroom. The class measures the length of each earthworm and records the data in a line plot. What is the difference between the lengths of the shortest and the longest earthworms? So really what we're going to be dealing with is a little bit about how to read and write line plots, but also how to solve problems comparing information on line plots. So before we get going with that, I just want to talk a little bit about line plots in general. Line plots are a way of showing frequency, which means how many times something occurs. So it's a way of displaying your data that shows in kind of a graph form what the comparisons would be for different numbers. So I've written an example up here using numbers of pets, and I did just kind of a quick poll with my friends. So the first one, Jess, is me. I have 2 pets. I have 2 dogs. So if I were to draw it out on a line plot, I'm taking my smallest number and starting with that, and my largest number and ending with that. So a line plot is like a number line, and it's going to be going from your smallest point to your largest point. Some number lines go slightly before the smallest point and slightly after the largest point, but in general, you want to make sure that your scale at least covers your smallest and largest points. I have 2 pets, so I wrote an X above 2. Each X represents one person's answer. So I said that I have 2, and the numbers on the number line are representing the number of pets. So I wrote an X for 2 for my answer. Now my friend Sharon, she also has 2 pets. So I drew in another X above my X, representing Sharon's number of pets. She has 2 pets as well. My friend John, he also has 2 pets. So I have 2 up there as well. So for a total now of 3 X's above 2. So that's showing that 3 people gave an answer that they have 2 pets. My friend Angela, she actually has 3 pets. So I wrote an X above the line, above the 3 for Angela's response. My friend Ashley has 0 pets, so sad for her. So I wrote an X above the 0 for Ashley's answer. My friend Erin has 6 pets. Who does that remind you of? So I went over to the 6 and I have an X over 6 for Erin's answer. My friend Melissa also has 0 pets, so I put another X above the 0 for Melissa's answer. And lastly, my friend Zoe has 1 pet, so I put an X above the 1 for Zoe's answer. So if I were to look at my data, I would see that 2 people of my friends that I polled have 0 pets. 1 person has 1 pet. 3 people have 2 pets. 1, 2, 3. 1 person has 3 pets. 0 people of the people that I polled have 4 or 5 pets, and 1 person has 6 pets. So if I were to use some information, the number of pets that the most people had would be 2, because that was the most number of X's. And the least number of pets that people had would be 4 or 5, because no people of the people that I polled had 4 or 5 pets. So again, your line plot is a nice way of showing the frequency with which something occurs. So our answer of 2 pets occurred the most frequently here. Okay, so let's get back to earthworms now. So you'll see in the example that it has lengths along the bottom. They have their lengths measuring from 4 in inches to 7 inches. So the scale is going to be between 4 and 7, but they also have fractional increments. So they have 4, 4 and 1/4 inches, 4 and 1/2 inches, 4 and 3/4 inches, 5 inches, 5 1/4, 5 1/2, 5 3/4, 6, 6 1/4, 6 1/2, 6 3/4, and 7. Okay, let's work through the problem. So it says A says, what do the numbers below the number line represent? That is, if you look at your title under your number line, that's going to tell you what those numbers represent. So if we look at the title, it says length in inches. So what do the numbers below the number line represent? Length in inches of the earthworms, because that's what we are measuring. So you would write the lengths of earthworms in Emma's class, or you could say length in inches of the earthworms. B says, how do you know which are the longest and shortest earthworms? Well, if you look on the chart, you can easily identify the shortest earthworm is 4 1/2 inch, because that's where the first X is on our graph. There's no X's before that, so we know that that is the earthworm that had the shortest length. The longest length would be on the other side. 6 3/4 would be the earthworm that had the longest length, because there's no other X's past that 6 3/4 mark. All right. C says, what are the lengths of the longest and shortest earthworms? Longest earthworm, again, is 6 3/4 inches. Shortest earthworm is 4 1/2 inches. D says, explain how to find the difference between the lengths of the shortest and longest earthworms. So when you hear difference, you think subtraction. So when we do subtraction, we're going to start with our largest number, in this case 6 3/4, and we're going to subtract 4 1/2. Now, we got to put on the brakes, because I notice right away that my fractions they do not share the same denominator. And so when you do not have the same denominator or the same numerator, it makes it really hard to compare your fractions. So our first step is going to be to convert one or the other into a corresponding fraction. Now, I know that 3/4 is more than 1/2, so it would make more sense for me to change my halves into quarters than it would to try to make 3/4 into halves, because then I would have half and a little bit more. I can't do it that way. So I'm going to change 1/2 into a certain number of quarters. So you'll remember from working with fractions that we think of our fraction bar is kind of like a balance. What we do to the bottom, we must do to the top. So I'm going to think about my end result is I want quarters on the bottom. I want fourths on the bottom. So what would I need to do to 2 to multiply to get to 4? Well, I know that 2 times 2 is going to equal 4. What I do to the bottom, I also, why can't that look like a multiplication sign? There we go. What I do to the bottom, I also have to do to the top. So I'm going to then multiply my 1 times 2 as well to get 2/4. Now we can double check this by thinking about our pie graph. If I have halves, I have 1/2 shaded in. If I then split it into fourths, how many fourths would I have? I would have 2/4 that correspond with 1/2. Those are equivalent fractions. Same value, different numbers. So I now have, instead of 4 1/2, I have 4 2/4, because that is an equivalent fraction. And now I can subtract. So I'm going to start with my fractional pieces, just like you would start with the ones column on your bigger numbers, because it can sometimes influence the others. We're going to do the same thing starting with our fractions, because it may end up influencing our whole numbers. So 3/4 minus 2/4, I would think I have 3 of the fourths, and I'm going to take 2 of those fourths away. I would be left with 1/4. And then 6 take away 4 would be 2. So there would be a difference of 2 1/4 inches from the longest earthworm to the shortest earthworm. All right, on page 283 it says to find the difference between the lengths of the shortest and longest earthworms. On the previous page you have to subtract 6 3/4 from 4, or I'm sorry, you have to subtract 4 and 1/2 from 6 and 3/4. The fractions have different denominators, but you can write equivalent fractions on the number line so that all the fractions have the same denominator. So they've done the same process. They've just gone through and replaced wherever you see halves with a certain number of fourths. So if we were to count on 4 and 1/4, 4 and 2/4, 4 and 3/4, and 5. So you can find it either by doing what I did, which was doing the conversion right in your equation, or you can also write it out on a number line. We're going to skip on down to number 1 where it says reflect, which is the most common length of earthworm in Emma's class. What is the difference between this length of earthworm and the length of the shortest earthworm? Explain how you found your answer. So there's 2 parts of this question. The first part is asking what is the most common length of earthworm in Emma's class. So what is the earthworm that happens with the most frequency? So just like on my example, the answer that had the most number of pets was 2. We're going to look for the earthworm that happened the most frequently, that has the most number of X's above the column. So if we look at that, we'll notice that 5 and 1/2 has 1, 2, 3, 4, 5 X's. That's more than any of the other answers. So 5 and 1/2 inches is the measurement of the earthworm that happened with the most frequency, or the most common earthworm length. Now the second part of this question says, what is the difference between this length of earthworm and the length of the shortest earthworm? So the length of the shortest earthworm, remember, if we look at the one that has that's on the shortest end of the scale, we have 4 and 1/2. So we said 5 and 1/2 was the most common measurement, and 4 and 1/2 is the shortest earthworm. So now to find the difference, again, we're going to subtract. So I have 1/2 and I take it away. I now have 0 halves. I don't have any fractions. 5 take away 4 would be 1. So the difference between the most common length of earthworm and the shortest earthworm would be a difference of 1 inch. Okay. Go ahead and turn the page to page 284. The problem says students in Mrs. Holbrook's class are growing plants. One day they measured the heights of the plants in inches. The heights are shown below. Make a line plot to represent the data. So it has 2 and 5/8, 2 and 1/8, 2 and 3/8, 2 and 7/8. So the first step that we're going to do when we are trying to figure out how to make a line plot is we're going to look for our ending number, the shortest amount, and our ending number on the other side, our longest amount. So as I'm scanning through here, I see, okay, there's 1 and 3/4, there's 1 and 5/8, there's 1 and 1/4, there's 1 and 1/2. Oh no, I don't know the difference between these. So I'm then going to go ahead and think about, I know that I'm going to be going somewhere in between 0 and 1 for my scale. So I would probably start with 0. And then I would have 1, and I would have 2. And then I know that I have fractions that go up to 3. Or I'm sorry, that go higher than 2, but not quite up to 3. So I'm also going to put, let me move this around a little bit. I'm going to have 3 as my ending place. I have 1 and 2. So this would be the range of my line plot, because I don't have any that are less than 1, and I don't have any that are more than 3. So you could maybe have 1 as your ending place, but it's nice to give yourself a little bit of wiggle room. So we're going to be focusing mostly on this area right here. Now, in order to more accurately reflect the data, we're going to have to use those fractional amounts, which means that I'm going to need to think about how many 8ths and 4ths and halves are equivalent to each other. So I'm just going to start off by marking halfway in between my 0 and 1, my 1 and 2, and my 2 and 3. So that's half. Now I'm going to take each of those sections and I'm going to cut those in half to make fourths. So we'll now notice that I have 1, 2, 3, 4 segments in between 1 and 2. Then I'm going to take those segments and I'm going to cut those in half because that's going to get me eighths. So then I'm going to have 1, 2, 3, 4, 5, 6, 7. Okay, so now notice I have 1, 2, 3, 4, 5, 6, 7, and then 8 would correspond here. So now I'm going to be thinking about, I have 1, let's go ahead and start with my 0 to 1. So I would have, my first one would be 1/8. My next one would be 2/8, but I know that 2/8 also corresponds with 1/4. Then I would have 3/8. Then I would have 4/8, which corresponds to 2/4, which corresponds to 1/2. Then I have 5/8. Then I have 6/8, which would equal 3/4. Oops, it looks like I skipped a line here. And then I would have 7/8. Oops, I should have wrote backwards. And then finally my 1 would be 8/8. So they've written it out on its own separate number line under Model It. It says you're going to count by eighths. I know that I'm counting by eighths because those are my smallest fractions. And if I'm counting by eighths, I will hit the same markers that hit fourths and halves. So if I just make my number line by eighths, I'm going to hit all of those places. So on this number line, they show you're starting at 0 and counting to 8/8, which is equal to 1. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. You can also use fraction bars. They've done a picture it for you to find equivalent fractions. So they're showing you that 1/2 is equal to 2/4 is equal to 4/8. So again, when you're going to fill in the numbers on your number line, you can figure out that for every every 2/8 that you have, you're going to have 1/4. For every 4/8 that you're going to have 2/4 or 1/2. So I know that may seem confusing. The next page is going to help us work out how to number our number line. So number 2 says use Picture It to help you write these fractions as eighths. So 1/2 is equal to how many eighths? So if we go to the number line that they have under Picture It, I'm sorry, not the number line. If we go to the fraction bars under Picture It, we'll see that 1/2 would be the same, would fall along the same path as 4/8. So we would write in a 4 as the numerator above the eighths. 1/2 is an equivalent fraction to 4/8. 1/4 would be equivalent to blank eighths. So we would look at the same thing. 1/4 ends at the same place that 2/8 would take up. So on the next page, so on page 285, 1/4 is equal to 2/8. Those are equivalent fractions. And lastly, 3/4 is equal to blank eighths. So you can still, even though you don't have that many fourths here, you can, if you have 1/4 is 2/8, 2/4 would be 4/8, 3/8 you would count on 2 more eighths, 2, 4, 6, you would have 6/8 that would be equivalent to 3/4. Number 3 says label the number line by eighths. So they're giving you a number line between 1 and 3, and they want you to go ahead and write it in starting at 1. You would have 1, the next one would be 1 and 1/8, 1 and 2/8, 1 and 3/8, 1 and 4/8, 1 and 5/8, 1 and 6/8, 1 and 7/8, and then 1 and 8/8, or 2 ones, which would be the same as 2. So then we're starting at 2 and going 2 and 1/8 would be the next one, 2 and 2/8, and so on until you get to 3. Number 4 says make the number line in problem 3. So you're going to be having a number line ranging from 1 to 3 because that's the spread of our data. Make a line plot of the plant heights below. So you're going to make the same number line as you did in 3 that you labeled. You're going to rewrite it in the space below number 4. You're going to go ahead and, okay, so you're going to start with your number line. You're going to start at 1 and end at 3. You're going to mark all of your fractional pieces. So 1 and 1/8, 1 and 2/8, 1 and 3/8, 1 and 4/8, 1 and 5/8, 1 and 6/8, 1 and 7/8, and then 2, 2 and 1/8, 2 and 2/8, 2 and 3/8, 2 and 4/8, 2 and 5/8, 2 and 6/8, 2 and 7/8, and then 2 and 8/8, which would be 3. Let me move that over so it's a little bit. Okay, so your first step is going to be to draw your number line. Then your next step is going to be to label each of your lines. What I would do to start off with, one way, because you'll notice that I kind of got off and my numbers weren't nice and even in between. I'm going to use that measure of halves again. So the first step is I'm going to write out 1 and 3 at both ends of my number line. Then I'm going to draw a 2 in the middle because that's halfway in between 1 and 3. Then I'm going to cut each segment in half. Actually, I'm going to do this in a different color because I think that will help. Okay, so each segment I'm going to cut roughly in half. It's okay if you don't have them exactly even, but this is going to guarantee that you have it a little bit more even than just trying to eyeball it. So I'm going to cut those in half. So those would be halves. Then I'm going to cut each of those halves in half. So now I have 1, 2, 3, 4 segments. I now have fourths. Then to get eighths, I'm going to cut each of those segments in half. 1, 2, 3, 4. So now I have 1, 2, 3, 4, 5, 6, 7, 8 segments between 1 and 2. And if I did the same thing between 2 and 3, I would have 8 segments there as well. So that's going to help you get those kind of nice, more even spacings with those, rather than just starting to draw lines and then realizing that you have this much space left at the end and they're not even and having to erase it. So I would recommend, first of all, once again, starting off with 1 and 3, drawing 2 in the middle, have those segments, have each of those segments, and then have those segments a third time so that you get your eighths. From there, then you can write in the labels. You're going to have to write real small, but you're going to write in the labels. This first one would be 1 and 1/8. Then you would have 1 and 2/8, which we know 2/8 is equivalent to 1/4. 1 and 3/8. 1 and 4/8, which we would know would be equivalent to 2/4 or 1/2. 1 and 5/8. 1 and 6/8, or 1 and 3/4, and 1 and 7/8, and 2. Okay, and you would do the same thing on the other side. Then make sure that you have your labels. So our title of our line plot is going to be Plant Heights, because that's what we're talking about. And we're also going to draw a label for our scale down here, which is going to be height in inches. And you can write that as height and then in parentheses the abbreviation IN for inches. So each of these is going to stand for 1 inch. From there, then you're going to write in your, you're going to go through your table. And the first number that I see is 2 and 5/8. So if I were to find that here, I would have 2, 2 and 1, 2, 3, 4, 5/8. I would draw an X above the line for 2 and 5/8. Then I would go to the next one in the table, which says 2 and 1/8. Draw an X above that one, and so on and so on until you've gone through all of the data in your set. Remember, when you come to the same number twice, so if I get to 2 3/8 again, I'm going to just go ahead and stack one x right on top of the x that I already have there. So it's going to take you a little bit of time to write that in. I'm going to move on. Please make sure you can certainly pause the video and come back to it, but please make sure that you are writing in that line plot. It's good practice. All right, number 5 says, describe how to make a line plot with data that includes fractions. So we're going to talk about the steps that we just did. First, we drew a number line. Second, we divided it into parts based on the smallest fraction. In this case, we're talking about eighths. So we wanted to divide each section into eighths. Third, we are going to go ahead and make sure that we have all of our labels in place. And then we're going to go ahead and mark an X for each time that data appears in the table. All right, number 6 is doing the same thing that we just did, only with different data. So Al records the length of some fish in inches as follows. Make a line plot of the data. I would strongly encourage that you guys do this on your own time so that you get more practice at drawing line plots. But we're going to go ahead and move on. We're going to move on to the next section, which is 286. So now we're going to be talking about adding with line plots and subtracting with line plots, and then I'll give you your practice pages. So on page 286, the problem says Sophia is making a border for a quilt. She wants to use leftover strips of fabric that are all 2 inches wide. She measures the length of each strip and records the information in a line plot. If Sophia puts all the strips together, what will be the total length? So they've shown you your line plot. You have length in inches ranging from 12 to 13. Lengths of strips of fabric is the title at the top, and then they have X's for how many of each strip of fabric that length that she has. Beneath it says picture it. You can use a picture to help solve with addition problems. Model it. You can also break up the whole numbers and fractions to help you add the lengths. So add the whole numbers first, 12 plus 12 plus 12 plus 12 plus 12, and then add the fractions, 1/8 plus 1/8 plus 1/4 plus 1/4. So, so in the picture, it says the picture shows the strips of fabric placed next to each other to make one long strip. And so you would have 12 1/8, 12 1/8, 12 1/4, 12 1/4. Because we're going in the order, we see that there are 2 strips that measure 12 1/8, 3 strips that measure 12 1/4, 1 strip that measures 12 3/8, and so on. And then we would be adding those up. The model it part is you're breaking up the whole numbers and the fractions to do both. On the next page, number 7 says write the fractions on the number line in eighths. So you would write below the numbers what the equivalent fraction would be in eighths. So 12 1/8, it's already written in eighths. 12 1/4, you would find the equivalent number of eighths that would make up 1/4. We know that 2 eighths equals 1/4. And you would continue on with all of those numbers so that they would go into eighths. To add, all the fractions need to have the same denominator, so that's why we're changing them into eighths. So the second part of that question says, why should you do this? Because we need to have a common denominator to add. Number 8 says write an expression to find the total length if Sophia puts all the strips together. So again, you would take all of the lengths. 12 1/8 happens twice, so you would have 12 1/8 plus 12 1/8. 12 1/4 happens 3 times, 12 1/4 plus 12 1/4 plus 12 1/4. So you would add all of the lengths from the original line plot together. What is the sum of the whole numbers? If you added 12 plus 12 plus 12 plus 12, you're adding it 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can think of it as 9 times 12. When I'm thinking of when I have 9 times 12, I'm going to go ahead and break up my 12 into 10 and 2 to make it easier for me. So I know that 9 times 10 would be 90. 9 times 2 is like double 9s, that would be 18. So if I added my answers together, I would get 0 plus 8 would be 8. 9 plus 1 would be 10. I would get 108 as my answer. So you would have 108 as the sum of the whole numbers. What is the sum of the fractions? You're adding up a certain number of 8s. So you have 1 8, 1 8, 2 8, 2 8, 2 8, 3 8s, 4 8s, 4 8s, and 6 8s. So that would be like adding 1 plus 1 plus 2 plus 2 plus 2 plus 3 plus 4 plus 4 plus 6. Now, whenever I have a long string of numbers like this, I always try to look for numbers that make 10 because it makes it easier for me to add. So I know that 4 and 6 make 10. Then I'm going to think, okay, well, I don't see any other ones that obviously make 10, but I do know that 3 and 2 together make 5. And 4 and 1 also make 5. And so those 5s together would make 10. So far I have 10 plus 10. Then the rest of these don't add up to 10, but I do know that 2 plus 2 makes 4, and 1 more would make it 5. So now I'm adding 10 plus 10 plus 5. That makes it a lot easier for me than adding up all of these small numbers. I have 10 plus 10 makes 20, and 5 more would make it 25. So you would have 25 eighths, right? Because we were taking our numerators, 1 8 plus 1 8 plus 2 8 plus 2 8. So I would have 25 eighths total. Now, that's an improper fraction, so I would want to see how many times 8 would I could put 8 into 25. So I would keep subtracting 8 from 25, because remember, it's really like subtracting 8 eighths. So I'm going to go ahead and erase the rest of this. So 25, take away 8, is going to leave me with, and that one's a hard one for me to do. I know that 8 and 8 make 16, so 1 less than 16 would be 15. So 25 take away 8 would be 17, because 7 and 8 make 15, plus another group of 10s would make it 25. So I'm not quite there yet, so now I'm going to take 17, I'm going to take away 8 more 8s. 17 take away 8 I know is 9, because 8 plus 10 would make it 18. So 8 plus 9 is going to make it 1 less, or 17. I'm still not quite there, so I can still take away, oops, 1 more 8, which would give me 1 8 left over. I can't take away, so that would leave me with 1 8 left over. So I took away 1, 2, 3 wholes, and I have 1 8 left over. So I'm going to take that and add that to the 108 wholes that I already have. And so I'm going to say, I'm actually going to flip these around because it makes it easier for me to think of as 108 plus 3. That would be 111, and I would still have 1 8 at the end. So you would have a total of 111 and 1/8 inches for the length of Sophia's quilt. Number 10 says, how do you solve a problem about adding fractions or mixed numbers in a line plot? So you would label the line plot using the denominator with the smallest fraction, list the numbers to add, and then for mixed numbers, add the whole numbers and the fractions separately. So first step, label the line plot with the smallest unit fraction. Next, you would list the numbers to add. And the last step is, for mixed numbers, you separate out the whole numbers from the fractions, add them separately, and then add them together. All right, numbers 11 and 12, I'm going to have you guys go ahead and complete on your own. So it says, what is the length of all the 2.5 inch strips combined? So you're just looking for 2.5 inches. And 12 says, what is the length of all the 2 1/4 inch strips combined? You're just looking at the 2 1/4 inches. Okay, go ahead and turn the page. We're now on page 288. Now we're going to be subtracting with line plots. So our new line plot says there are many kinds of dragonflies that are different in length. A scientist measured the lengths of different kinds of dragonflies and made a line plot to show the measurements. What is the difference between the lengths of the longest dragonfly and the shortest dragonfly? So again, difference is telling us that we're going to be subtracting. They have picture it. You can use the length of the longest dragonfly, the length of the shortest dragonfly, and see what the difference would be. You can model it using a number line, starting with the longest one and making a certain number of jumps down to the shortest one and counting up the number of jumps. We're also going to go ahead and show another way to solve it on the other page. So 13 says the length of the longest dragonfly. If we look at our line plot, we find that the longest one, the one where the last X is 4 7/8 inches. And the length of the shortest dragonfly would be on the other side. We would see 3 1/4 is the first, where the first X's appear. So 3 1/4 inches is the shortest length of the dragonflies. Write an expression, number 14 says, write an expression that can be used to find the difference between the two lengths. So again, we would take the longest length and subtract the shortest length. Now, I can already tell that I do not have the same denominator, and so I'm going to need to change that first. So I have 4 7/8. I'm taking away 3 1/4. So I'm going to need to convert my fourths into eighths because eighths are the smaller units. So again, just like when I was trying to convert fourths to halves, I can't make halves into a certain number of fourths because it's not going to be equal, but I can make fourths that equal up to 1/2. So I am going to see how many eighths I would have in fourths. So I'm going to think about what would be an equivalent fraction that would have eighths. So again, what do I do to the bottom? I'm going to multiply 4 times some number to get 8. I multiply 4 times 2 to get 8. What I do to the bottom, I have to do to the top. 1 times 2 would equal 2. So 1/4 would be equivalent to 2/8. So really, I could also write this as 3 2/8. So now I can subtract to find. I have 7/8 take away 2/8. 7 of something take away 2 of something is going to get me 5. And in this case, it would give me 5/8. And 4 take away 3 would give me 1. So there would be a difference of 1 and 5/8 between them. So 15 says, look at the model it, explain how you could use the number line with arrows to find the difference between the two lengths. So you would count the number of jumps going from the longest to the shortest. Number 16 says, describe another way to subtract the two lengths by first writing the numbers with the same denominator. That's what we did. So first step, we changed fourths into eighths. The next step was then that we subtracted our fractions, and then we subtracted our whole numbers. All right. Number 17, I'm going to let you guys do on your own. It says, what length are the greatest number of dragonflies? What is the difference between this length and the shortest length? So greatest number, they're not looking for the greatest length. They're looking for the number, the most common length of dragonflies. So the one with the most X's on your line plot. And then you're going to subtract the shortest amount from that. Okay, I'm going to let you guys do that one on your own. The practice pages that I'm going to set for you guys are pages 293 and 294. That's just one double-sided page for this lesson. A note too, I'm going to continue to put out a lesson each week. You guys have 4 more sessions, so there are some lessons that are going to be combined, but we have 4 more online lessons that I'm going to be doing. We have about, I think, 8 weeks left of school. So you will have time to finish up. So I'm going to continue to put out lessons each week. If you need extra time to finish it, remember this time is more self-directed, so you can go at your own pace. So if you need more time to work through a lesson, that's fine. The videos will be there when you are ready to move on to the next lesson. So work at your own pace. Okay, I'll see you guys next time. Bye.